Video solutions for the CRT practice test 23 through 32. Number 23, the point 3, -4 lies on a line that intercepts the y-axis at -6. What is the equation of the line? Let's go ahead and make a graph of that. So, point 3, -4, so that's over 3 down 4 right there, lies on a line that intercepts the y-axis at -6. So here's -6. So we know that that's the y-intercept. We also know this is another point, so obviously the line that goes through both of them like that. So we can find the equation by, again, using the y-intercept, which they told us. It intercepts the y-axis at -6. And then we can find our slope because we have another point. So that's up 2 and over 3. Up 2 and over 3. So we know that up 2 and over 3, or 2/3, is my slope. And my y-intercept is -6. Another way to write that is 2/3 x minus 6, which is letter C. Okay, 24. A flagpole is 20 feet tall. A 50-foot wire is stretched from the top of the flagpole right here to a point on the ground. On the ground is pictured below. So that's called a guy wire. It keeps this flagpole steady. Which is closest to the distance from the base of the flagpole, that would be right here, to the point where the wire touches the ground right here. So we know this is a 90-degree angle, so we're simply using the Pythagorean theorem. We don't know one of the sides, so we'll call it B. So we know A is 20 squared, B is unknown, C is 50 squared. So that's 400 plus B squared, that's going to be 2,500. So we have to subtract 400 on each side. They cancel. So B squared equals 2,100. And then we know we have to find the square root. So B equals the square root of 2,100. Well, here we have some possible answers, so we don't want to use a calculator. We know it's not 8. We know 30 feet would be 30 times 30. That's 900. So it can't be that. So we have 46 feet. So 46 times 46 is 7, 24, 18. So that's about 2116. Well, that's very close. So I don't need to check the 54. So my answer is C. Right, number 25. The scatter plot below shows the distance some garden snails traveled and the amount of time each snail spent traveling. So here's your miles. So obviously it's not very far. Okay, and then here's your time. So it takes them a long time to go a very short distance. A linear model of the data is shown on the scatter plot. So they're giving you this line right there. We know that a line of best fit, which is what that linear model is called, basically cuts all these data points in half. So we want some on the line, but we want an equal number above that line and below that line, even though it's kind of at an angle. So what does the slope of the linear model represent? Well, we have basically a graph of a line. We can do slope triangle. So I go up and over. So I'm going up time over, or up miles and over time. So the total amount of time each snail traveled. So what we have is we have miles on one axis and hours on the other. So the total amount of time each snail traveled, yes, it does give us that, but it also gives us miles. So that's not the only thing. The total distance each snail traveled, yes, it gives us distance, but it doesn't tell us anything else. So we do have hours on our graph. The amount of time in hours it would take a snail to travel 1 mile. No, because it's only going 1/10 of a mile up here, not the whole mile. So we're left with D, which is the average speed in miles per hour of the snails. And that label gives us both this x-axis, the y-axis, and this axis, the x-axis. That's what the slope is. It's miles going up and hours going over. Miles going up and hours going over. Miles going up and hours going over. That's your rate of change. So your slope always tells us what the graph is talking about. Number 26. Which set of ordered pairs does not represent a function? Well, this is kind of confusing looking at it like that, so I'm going to put them in table form. So I have 1, 1, 2, 2, 3, 3, 4, 4. Well, all of these x coordinates are different, and we know that a relationship between two quantities that's not a function would have more than one x be the same, which then doesn't give us unique y's, because we know a function has for every x input, there's only one y output. So the next one, if we draw a table, I have 1, 2, 2, 3, 2, 4, and 3, 8. Well, right away I notice that the same x is being used twice. Well, again, we know that a function has for every x input, there's a unique y. So if I use 2 twice, I should get the same number twice over here, and I don't. So when I substitute 2, I get 3. When I substitute 2 again, I get 4. That can't happen. So if we look at a graph, okay, let's actually just sketch it. Over 2, up 3, and over 2, up 4, we notice that whenever this situation happens where I have the same x giving me two different y's, one point will be above the other. Well, we know that we can do the vertical line test. So if I draw a line straight down and it crosses more than one place on that function, or on that graph, it's not a function. So anytime you have a vertical line crossing 2 or more points, it's not a function. So we know that's B. 27. An animal cell has a diameter of 1 times 10 to the negative 5 meters. A bacterium has a diameter of 2 times 10 to the negative 7 meters. How many times as great is the diameter of the animal cell as the diameter of the bacterium? How many times as great is the diameter of this than this? So this, they're saying, is larger than this one. So if I write this out like that, you can actually, see that we're given a division problem. Because anytime I say how many times is great, that would be like saying somebody earns $10 an hour, somebody else works $40 or earns $40 an hour. How many times larger is this than this? Well, you would divide them. 4 times as big. Or if I turn it around, okay, how many times smaller is that? Okay, that's 1/4 as big, so I can divide it that way. So here we have scientific notation that we need to divide. Numbers with numbers, powers with powers. So 1 divided by 2 is obviously 0.5. Okay, when I divide, I need to subtract the exponents. So that would be 10 to the negative 5 minus the negative 7. Do your same change opposite. So that's actually going to be 10 to the positive 2. Now, the only problem with this is that's not scientific notation. I need to have it between 1 and 10. So I have to move that decimal over right there. So it's going to be 5 or 5.0. But if I move the decimal to the right, that means I'm getting closer to this. So instead of 10 squared, now it's really only going to be 10 to the first power, which is letter A.
So number 28, Marianne has a mound of snow in her driveway. The mound is in the shape of a cone, don't know how she did that, but with a diameter of 4 feet and a height of h feet. Marianne makes spherical snowballs with the radius of r feet from the snow. Which expression could be used to determine the maximum number of snowballs Marianne can make from the snow in the mound? Okay, well, let's draw our shape. So here we have our cone. Okay, and there we have our snowballs. Now let's put our information in. We know the diameter of the cone is 4 feet, and we know the height of the cone going straight up, is h. We know the radius of the snowballs are r. Now they're not asking us how many, they're just asking us the relationship between the volume of the cone and the volume of the spheres that we pull from that cone. So think of a pan of brownies, maybe a little bit easier to understand. And I divide this pan up. How many of these little rectangular shapes can I pull out of that pan? So again, here are the words divide. So I'm going to take this cone and I'm going to divide it up into snowballs. So I'm essentially taking the volume of the cone and dividing it by the volume of the snowballs. So we know our volume for a cone is pi r squared height divided by 3. We know the volume of a sphere is 4/3 pi r cubed. Now I'm using that formula because I tried this using the formula that we also used in class, which was 2 pi r squared height divided by 3. And that didn't work, so they're making us use this formula. Now, we do have one piece of information. We know this is 4. So we know the radius is 2. So I'm going to substitute that 2 into the volume of the cone. So my new formula would be pi 2 squared height divided by 3. So if I write it correctly, 2 squared is 4. We always put the number in front of the symbol. So 4 pi times the height divided by 3. We don't have any other information about the sphere, so I don't have to worry about that. Whoop, too big. So now, let's go ahead and divide the formula for the cone divided by the formula for the spheres. And that's how we would get one of these new expressions. So, I'll do it in blue. Okay, 4 pi height divided by 3, that's the formula for the cone with the radius in there, divided by formula for our spheres, 4 pi r cubed divided by 3. We know from fractions that when we divide we do same change flip. So I have 4 pi height times 3 times, and then I flip this to its reciprocal. So 3 on top and 4 pi r cubed on the bottom. Now I can start canceling. I have a 3 on bottom, 3 on the top. 4 on the top, 4 on the bottom. Pi on the top, pi on the bottom. So what am I left with? I'm left with an h on the top and an r cubed on the bottom. And of course that matches b. So this is a little harder. Remember, you can manipulate formulas to do what you want them to do. 29. A group of 400 people is surveyed. The people are asked whether their hair is short or long and whether they would select a comb or brush as a gift. The two-way table below shows the results of the survey. So right here. Which two-way table shows the relative frequency? What they're doing is they're taking the information and changing it into decimals, or what we might consider percents, except for they're not moving the decimal, of people with short hair who selected each gift, and the relative frequency of people who with long hair who selected each gift. So the first thing is you have to know how to read this table. So of the people with short hair, there's 150. 120 of them chose a comb, 30 chose a brush. Of the people with long hair, there was 250. Of those, 120 chose a comb, 130 chose a brush. So all we have to do is take these numbers and change them into decimals. So we divide. 120 out of 150 chose a comb. 30 out of 150 chose a brush. So I'm just rewriting the table. 120 with long hair chose a comb out of the 250, and 130 chose a brush out of the 250. And now we just divide. So I can cancel those, and I'm going to make this shorter. 12 divided by 15 is going to be 0.8. Cancel the zeros. 3 out of 15 is a fifth, so 0.2. Okay, down here, cancel. 12 out of 25 is going to be 0.48. Cancel these. So 13 out of 25 is 0.52. I'm just dividing to make decimals out of them. So now which one matches? And we're over here. 0.8, 0.2, check. 0.48, 0.52, check. So is answer D. Larry creates two linear functions of x. Function 1 is represented by the table, right here, and function 2 is described by the equation, remember, with slope-intercept form. Which statement about the functions is true? So this type of problem you have to read each one and see which one works. The y-intercept of function 1 is greater than the y-intercept of function 2. Well, here's our y-intercept here, so that's positive 1. Oh, I'm sorry, negative 1. Okay? Well, we don't see our y-intercept there, so we're gonna have to make it. All right? We know that the y-intercept is when x is 0. Okay? So, what I'm doing is I'm adding 3 each time. Oh, I guess I'm not adding 3 there. They got off a little bit. So, I'm going to need to create an equation for this to find the y-intercept. So, let me see. I'm adding 3, adding 6, adding 3, adding 6. So there's my pattern. So we know the slope is 3 over 6 or 1/2. Okay? Now, to find the y-intercept, I'm going to go back to 0 here. So, to get back to 0, that's only one difference, isn't it? But I have adding 3, so I'm doing 1/3 of it. So what I do is going back this direction, I'm going to take 1/3 of the 4. Because I only went back 1/3 of this pattern. So 1/3 of 4 means 1/3 times 4, which is 4 over 3, or 1 1/3. So that's my y-intercept. So my equation for this top one is y equals 1/2 x, my slope goes in front of the x, plus 1 1/3. Okay, the y-intercept of function 1 is greater than that of function 2, and you see it already is. So that's going to be our answer. So that was kind of a hard one. Okay, 32. The scatter plot below shows the different amounts of gasoline people purchased at different prices per gallon. So here's our price, dollars, and here's our gallons. Okay, so you see that when they didn't buy very many gallons, the price was higher. When they bought more gallons, the price was lower. Okay, so the data set does not contain any outliers. We're looking for which one is true. Well, an outlier means it's a place where there's not a lot of other points. Well, if you see this one over here, that's way away from all these. So that's called an outlier. So there obviously is one of those. So that's not true. There is a positive association between the number of gallons purchased and the price per gallon. They're basically talking about slope. So if we kind of draw a line that goes between these, you can see it goes down and to the right or up and to the left. We know that that's a negative slope. They're telling us it's positive, so we know that's not right. There is a negative association between the number of gallons purchased and the price per gallon. Well, we just said that. Okay, so we have a negative slope, so that's a negative association. They're just using some different words, so our answer is C. All right, hopefully this helped you.